The second new symbol that we are going to encounter today is the so-called turnstile. The turnstile looks like this little symbol in the upper left corner there. And the sentence, A1 to AN turnstile C, means that there's a proof from premises A1 to AN to conclusion C. Now, strictly speaking, we would need to specify the proof system that we have in mind. So strictly speaking, we would need to say that A1 to AN turnstile subscript TFL C means that there's a TFL proof from premises A1 to AN to conclusion C. And the reason is that there are many different proof systems, and just because a sentence can be proven from given premises in one proof system doesn't mean that it can be proven from these premises in any other proof system. Now, so that's why when you look into advanced logic textbooks, you're often going to see the turnstile with little subscripts referring to different proof systems. But since in this class we have not introduced any other proof system other than the TFL proof system that we are using, we will omit the subscript and tacitly presuppose that we are talking about TFL and the inference rules that we have studied in the last couple of weeks. Now, a theorem is a sentence that can be proven from the null set of premises. And we can express this property using the turnstile. So when I say turnstile C, that means that C is a theorem. And you can see that here to the left of the turnstile, there's nothing, no further sentences to the left of the turnstile. And so what I'm saying is that C can be proven from no premises whatsoever, and that's just what it means to be a theorem. Now, a proof of a theorem has nothing above the main Fitch bar, or very often people who prove a theorem also simply omit the main Fitch bar, meaning there's no Fitch bar perpendicular to the main vertical line. Now, two sentences A and B are provably equivalent if and only if each of them can be proved from the other. And so we can express provable equivalence by means of the turnstile, that is, by saying A turnstile B and B turnstile A. Finally, sentences A1 to AN are inconsistent if and only if a contradiction can be derived from them. That means that sentences A1 to AN are inconsistent if and only if A1 to AN turnstile bottom. Otherwise, A1 to AN are consistent, meaning A1 to AN are consistent if and only if we cannot derive a contradiction from them. So let's finish off our discussion by comparing the double turnstile with the turnstile. The double turnstile has to do with truth tables. A double turnstile C says that every valuation that makes A true also makes C true. And that's a property that we can read off in the joint truth table of A and C. And double turnstile C says that C is a tautology. Now the turnstile, on the other hand, has to do with proofs. A turnstile C means that there is a proof of C from premise A. And turnstile C means that C is a theorem. So here's a little crutch to help you remember the difference between the turnstile and the double turnstile. So this is the double turnstile, and you can see it actually looks a little bit like a part of a table. So you can kind of extend it like this, and now it looks like a truth table with the different rows, A, B, A, or B, and so on and so forth. And you can fill in the detail. So the double turnstile looks a little bit like a part of a truth table, and just think of this image when you try to remember the meaning of the double turnstile. The double turnstile always has to do with truth tables. Now, the turnstile, on the other hand, always has to do with proofs. And here's a crutch to help you remember this fact about the turnstile. The turnstile actually looks a little bit like a proof with a Fitch bar attached to it. And so above the Fitch bar, we put our premise, say A, and at the bottom of this vertical line, we put C. So I hope that this image is going to help you remember that the turnstile always has something to do with proofs.